In this video, we're going to look at some more coordinate geometry questions. So in the coordinate diagram below, we've got 16 points marked with a dot. Louise is going to pick one point at random from the 16 points marked with a dot in the diagram. She finds the equation of the line that goes through this point and 0, 0. Find the probability that this line has a slope greater than 1. So our knowledge of slopes. So the best thing to do here would be to draw the line that has a slope of 1. That's going through 0, 0. So the point 1, 1, 2, 2, 3, 3, 4, 4, the same rise and run if we drew a triangle with any of these. So the question we have to ask ourselves is it below the line or above the line that has a slope greater than 1? So let's look at this triangle here. We could use the points as well. We have a run of 2 and a rise of 1. So the slope of this line, m, is the rise over the run, which is 1 over 2. And then above the line, I'll take this point here, draw my triangle. So you can see here, just recreate the triangle outside the diagram. The rise is 3 and the run is 1. You can see the slope of this line is 3 over 1. So it looks like all the points above the line will have a slope greater than 1, and all the slope points below the line, the run will be greater than the rise. So many points we left? 1, 2, 3, 4, 5, 6 above the line, and there were 16 altogether. Greater than 1, 6 over 16. Probability, we don't have to simplify our fractions, but you could see that this will be 3 over 8. Part B, how many of the 16 points marked with a dot in the diagram are exactly 5 units from the point 0, 0? So exactly 5 units. Your knowledge of trigonometry here, our 3, 4, 5 triangle. So let's just pick one of them to start with. That's up 4. So if we take this line to start with, I'll just recreate the triangle in this box. I've gone out 4 and up 4 to the point 4, 4. So out and up 4, so the diagonal is the square root of 4 squared plus 4 squared, which is equal to the square root of 32, which is above 5. The square root of 25 is 5, and the square root of 36 is 6. So this is in between 5 and 6, so it has to be shorter than this. So the knowledge that we need here are the triangles that you would have seen over and over again at junior cert. 3, 4, this diagonal here. So this point here is going to be the point 3, 4. If I just come to the side here, I've gone out 3, up 4, and you know this is the 3, 4, 5 triangle. If you don't, you're not watching these videos. So that point there, the big red dot, is definitely 5 away. So we'd have to have a 3, 4, 5 triangle for them to be 5 away. Let me get rid of these lines and we'll do another one. So we went out 3 and up 4. What about out 4 and up 3? This one here is also going to be 5 away. You can see we've gone out 4 and up 3. So this line will be 5 as well. So 2 of the points, it's only 2, that will be 3 and 4 away. This one, and 3, 4, this one. So 2 is the answer here. Next part of this question. Actually, that was the whole question. So the next question, coordinates of points. Easy start. The shop first, just don't mix them up. Start here, back 3, up 1, minus 3, 1. Home next, out how many? 1, 2, 3, 4, and up 2. Out 4, up 2. And then school, we're going out 4 and up to 5. Out 4, up 5. The library is the midpoint, so your basic coordinate geometry knowledge of midpoint between the home and the shop. So let's connect home and shop, and let's look for the midpoint. You'd use a ruler in an exam. So the midpoint, the way I teach my students, we write the 3 points down, or the 2 points down to get the third one. Minus 3, 1 and 4, 2. Midpoint is where we add together. Add and divide by 2 will give us the midpoint. 4 minus 3 is 1. divide by 2 is 1 over 2. 2 and 1 is 3, and divide by 2 is just 3 over 2. So not too difficult there. A half on the x-axis, 3 over 2 on the y-axis. Here's a half. Here's 1.5, and you can see that definitely looks halfway. So 1 over 2, 3 over 2. Part C, we're asked to work out the distance, so the length of the line from the home to the shop on the diagram. Let's have a look. Home to shop, same points. So home to shop, we're looking for, when we're dealing with distance, it's the change in x to be squared plus the change in y to be squared. That helps us with slope as well. So the distance from home to shop, the change in x, 4 down to minus 3, so 7 is the change. And we have a 1 to 2, 1 is the change. So we're going to have the square root of 50, 49 plus 1. Square root of 50 works out to be 7.07. What way do they want this question answered? 2 decimal places, so 7.07. Then the distance on the diagram from shop to school is 8.1 centimeters. The diagram has a scale of 1 centimeter is 2,500 really. So the actual distance will be 8.1 by 2,500. So calculator use here. 2250 it's given me. So this is in centimeters. Now obviously when you get these questions, read them carefully. The answer is in meters. How do you change centimeters to meters? Divide by 100. Just move the decimal 2 places. 202.5 meters. That's 5. Or imagine the decimal is here and you're moving it in 2 places. 202.5. Next part, Cleena walks from the shop to the school. Explain why the distance she walks is probably more than the distance from part A. So these are kind of junior cert questions with no maths involved. Well, can she walk directly? Probably not. So that's probably what you'd write here. Can't walk in a straight line. Or can't walk through buildings, or whatever you come up with here. There will probably be buildings in the way. Don't try and be too smart. Just write something that makes sense. Parts F and G here deal with slope and equation of a line. We're looking work out the slope of the line L. So this is the line L from shop to school. So let's complete our right angle triangle to get our rise and run. So we're running from -3 to +4. Do another sketch of the triangle. It's just a sketch. We're running 7. We're rising from 1 to 5. So we're rising 4. So the slope, you can see it's positive from your knowledge of coordinate geometry, is a rise over run. Answer is a fraction we have. And then the equation of the line L, we can use either point. So let's use the positive one here. We have the point 4, 5. Write down the point you're using and the slope. And then into the formula, y minus y1 equals n times x minus x1, but you all know off by heart. Y minus 5. Just don't mix up the x and the y. Y minus 5 is equal to 4 over 7 times x minus 4. Multiplying both sides by 7. 7y minus 35 is equal to 4x minus 16. And then just check the way they want it written. Everything on the same side of the equal sign. So x is positive. So bring it all over to the x. 4x to 7y is going to become negative. And then we have minus 16 plus 35. If you jot that off to the side, minus 16 plus 35 and type it into your calculator if you're not sure, we'll give 19. So plus 19 equals 0. What I would like you to do in this case is put the second point in to make sure it works. The second point is minus 3, 1. So 4 by minus 3 would be minus 12. Minus 7 by 1 would be minus 7. Then we have the plus 19. Does that equal 0? And you can see that it does. So you've gone ahead with confidence. You know you're correct. And the last part, the last kind of thing they can ask in coordinate geometry, to bring a bit of trig in here, use trigonometry and the slope of L. So we got the slope to be 4 over 7. To find the angle that's in here, just let's double check that's where it is. You see here the angle A on the diagram. So we have the two straight sides. So your knowledge of SOHCAHTOA, you probably don't need it, but when you're using the two straight sides, the opposite and adjacent is tan. So we can say the tan of the angle A is equal to O for A7. So you type into your calculator the inverse tan of 4/7 to get the size of the angle A. So calculator use, the inverse tan of 4/7. Use the fraction button on your calculator. We'll give 29.744. 29.744, and this is when I look and see what the question asked me. 1 decimal place, 29.7 degrees for the angle A. And that completes this video.